All right, today we're going to talk about fats and how they go from plate to stomach and then into the body. Now, fats are a difficult one to metabolize for our body because they are water insoluble, meaning they are hydrophobic. They don't like water, and our water enzymes and everything that works in the body is pretty much water soluble. So it's difficult to interact with something that doesn't like water and stays away from water. Think about when you have a hot frying pan full of fat and you pour water on that. The energy in there, because of the heat, they jump away from each other. They do not like each other. Okay, so the body's having difficulties with the breakdown of fat, and we use substances known as emulsifiers to interact and get the enzymes to break down those fat and then release the 9 calories per gram. Now, there are 3 different types of fat that we really consume: triglycerides, phospholipids such as cell membranes, and sterols like cholesterol. Now, 98% of all the fats we consume are triglycerides, so that's really one I want to focus on. A triglyceride, tri, meaning there are 3 fatty acids on a glycerol backbone. Those fatty acids can be separate or they can be together in a triglyceride, and they can come in different lengths. Now, we know fat lengths as short, medium, and long. A short fat chain is 2 to 4 carbons in length, a medium 6 to 10, and a long greater than 12. And so let's talk about how that goes through our digestive system and into the blood. We start our process as we chew our food and we increase that surface area and have this mechanical churning in our mouth. We also release an enzyme in our saliva known as lingual lipase, and that's going to start breaking down our triglycerides. Again, it doesn't stay very long in the stomach. We're going to swallow that and it's going to end up in our stomach. That's going to denaturize the enzyme, so that's no longer active, but the stomach actually releases a gastric lipase, which continues to break down those triglycerides into a diglyceride. 3 fatty acids, triglyceride into diglycerides, 2 fatty acids, and a free fatty acid. So we started that digestive process, and it is then passed to the small intestine, to the duodenum. More interactions happen. The duodenum releases a hormone known as cholecystokinin. Now, this is a messenger that goes to the gallbladder to release bile and to the pancreas to release emulsifiers that are released into the small intestine and surround the fat like grit on oil. And so if you think about how you clean up an oil spill ever, you don't wash it, you cover it in a grit like cat litter. Okay, you want it to be absorbed. Okay, so that's what the cholecystokinin is doing. It's telling the pancreas to release emulsifiers and the gallbladder to release bile, which contains salt, and lecithin, another emulsifier. Those surround the fat molecules and help the absorption process. Now, the cholecystokinin also causes the release of secretin. Okay, and a secretin causes the release of bicarbonate from the pancreas. That bicarbonate is important because it neutralizes the stomach acid. Okay, if we have a lot of acid that comes from the stomach into the small intestine, that denatures the enzymes. Now, we don't want that to happen. We want a enzyme to be present so we can digest our food. The pancreas has another role here. It's going to release pancreatic lipase to finish the breakdown of the diglycerides into monoglycerides, glycerol, and free fatty acids. At this point, they're ready for absorption within the jejunum. Small and medium chain fatty acids, along with glycerol, can be passively diffused through the intestinal wall, whereas long chain fatty acids and monoglycerides that haven't been yet broken down have to be facilitated through. This process is a little bit more complicated, so I'm going to put an image up for you to see. The monoglycerides and long chain fatty acids are absorbed and reassembled into triglycerides inside the intestinal wall. They're resynthesized and then combined with protein carriers to form lipoproteins. These lipoproteins you've probably heard of, such as HDL and LDL, carry this fatty cargo and pass through the intestinal wall, and when they leave, they're known as chylomicrons. The chylomicrons and then pass through the lymphatic system to the body via the thoracic duct. Now, once into the body, they can be either used for aerobic energy production in the mitochondria, or they can be stored for later use. Either way, a lipoprotein lipase will break down the chylomicrons, releasing the free fatty acid and the glycerol backbone. The free fatty acid can be metabolized, and the glycerol can be transported to the liver to undergo gluconeogenesis. That's how we use it. I hope you learned something. That's how fat goes from plate or food into the body and subsequently used for energy production. I hope you learned something. Remember, give me a like, comment, and we'll have discussions in the comments below. Thanks.